class. Today we will look at computer arithmetic. In this chapter, we have addition, subtraction, multiplication, division, and floating point
Floating
arithmetic
point
operation.
arithmetic operation,
Okay.
decimal arithmetic unit,
No,
decimal arithmetic operations.
no, these two are not there in the syllabus.
Okay, ma'am.
Only up to floating point arithmetic operation is in the syllabus.
Okay, ma'am.
We'll check in the syllabus. Addition, subtraction, multiplication, division, floating point.
Yes, ma'am.
Okay. So today we will try to complete addition and subtraction. Arithmetic operations in digital computers can be performed on signed magnitude, signed numbers and unsigned numbers. There are different ways to represent um, numbers. Uh, do you remember in how many ways you can represent signed numbers, negative number representation? Do you remember? No. Signed numbers can be represented as um, signed magnitude, one's complement, two's complement. Okay. So signed magnitude means you negative number will have a uh, mm, number part and sign part. We divide the negative number into sign part and number part. So number part we take as it is, and sign part we denote with 1. If we use 1, it indicates that it is a negative number. If it is 0, it indicates that it is a positive number. So um, you can perform operations on these numbers using some algorithm. What is an algorithm? An algorithm is a step-by-step procedure to perform a particular task. Uh, Here in this topic, we will study about start addition and subtraction with signed magnitude data. Okay, signed magnitude data. Signed magnitude means uh, you separate the number into number and sign part, and number part directly you convert into binary form, and then if it is negative, it is denoted by 1. That is how this addition subtraction with sign magnitude um, algorithm functions. So magnitude, uh, if you are representing minus 10, then 10 is the magnitude, minus is the sign. When you represent plus 20, 20 is the number, plus is the sign. Number means magnitude. Can you explain me these rules? You know these rules since schooling we are studying these. Addition and subtraction of signed magnitude numbers. Yes, Bhavna. Hello, Bhavna. Okay, some other students have also joined. Saraswati, Shravani, can anyone explain me this rules of addition and subtraction?
Ma'am, like plus into plus becomes plus, plus and minus becomes minus like that, na ma'am.
Like that only. We are
Okay, ma'am.
performing an operation here in
At
first four cases. The operation is plus. Last four cases, the operation is minus. Now what happens, you tell me, if both the numbers are positive, if one number is positive and another is negative, what is the general rule?
uh, two positive numbers becomes positive, ma'am. Two negative numbers will also be positive,
Hmm.
and one negative and one positive becomes negative, ma'am.
Yes, um, you are right, very good. So what happened here is, when you have plus operator and if the if the signs of A and B are identical, then you perform which operation? Addition operation, right? Plus plus
Yes,
plus
ma'am.
plus plus plus, minus plus minus 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 plus. When you have identical um, operations operators, when you have identical signs, actually signs, there are two operands A and B, you are going to perform um, plus operation or minus operation. When you are performing plus operation, if both the operands, the signs of both the operands are plus or minus, then the operation you perform is addition. Otherwise, you perform subtraction. Um, in the case of subtraction, when the signs are different, signs of the operands, when the signs of the operands are different, then you perform plus operation. Otherwise, you perform minus operation. So, plus A plus plus B. So, what operation you have to perform? Plus operation, because both are identical and the result is also positive. Plus plus result, whatever result you get, that is that whose sign is plus. Plus minus, when it is a addition operation and operators here signs of these two operands are different, then the operation which you are performing is minus, not plus.
Subtract.
Yes, it is subtraction. So this plus
Yes, ma'am.
will become minus. What will be the sign of the result? That is determined when you compare the magnitudes of both the operands. When A is greater than B, when A is greater than B, then the the result is positive. When A is less than B, the result is negative. When A and B are equal, then the result must be positive. You cannot have negative 0. You should have positive 0 only. So these all cases says that whenever you are performing a subtraction operation between two same numbers, then their sign must be plus. If I say 5 minus 5, results should be plus 0, not minus 0. That's why specifically here plus is prefixed to this operation. When a addition operation is performed between two operands where one of them is my negative, then it depends on the the sign of the result depends on which one is greater. When A is greater than B, then the result is negative. When A is less than B, then the result is positive. In this case, essentially this minus minus, because of two minus, this uh, result will be minus, but operation is plus. Okay, the result will get a negative sign. And then these four cases, operation is subtraction. When the signs of uh, two operands is are different, then you convert this minus operation into plus operation. When the signs are identical, then you perform minus. When A is greater than B, then the result gets plus sign, otherwise minus. Here um, minus A minus plus B result is equal to minus A plus B, because here A, the first operand is minus. Here minus A minus minus B is A minus B, and result is negative when A is greater than B, positive when A is less than B. I hope that this table of addition and subtraction of sign magnitude number is clear to you all. How are we implementing this one in hardware? That is the question now. Look at this. We require two registers to store two operand values. Register A, register B. We require a um, we require two flip-flops, BS and AS, to store the sign of A and B operands. A register will hold the value of A, and the sign of A is stored in AS. And if you remember, plus means 0, minus means 1. In this, if you are having a value 1, it indicates that the number in A register is negative. Here in AS, when you find 0, it denotes that A register has a positive number. Likewise for B register and B sign. Okay. Now these two, if you remember, if you can just recall that concept in which we have constructed a binary adder subtractor. We have a mode bit, then m mode, and then XOR gate we used, and then A and B. um, if mode is 0, then it performs addition. If mode is 1, it performs subtraction. That one circuit we have constructed, if you recall. Likewise here also we have a this part is like our circuit which performs the actual addition or subtraction operation. This parallel adder will add the result, and will add the A register and B register contents, and store the result in accumulator. And E, if you remember, E is a extended flip-flop that holds the overflow bit. Whenever there is an overflow, that value you store in E, or it can be carry also. You can also store a carry. AVF is overflow flip-flop, and this complementer, if you are performing a subtraction operation, can anyone tell me how subtraction operation is performed on a digital computer? Yes, can anyone tell me subtraction operation, how is it performed on a digital computer? No one? No one remembers? uh, we take 2's complement, add the minuend to the 2's complement of subtrahend. Please recall this. To perform subtraction, add the minuend to the 2's complement of subtrahend. When when the sum generates a carry, the result is in positive, and uh, obtain the result. When no carry is generated, the result is negative, and to find the result, to take the 2's complement of it. If you remember this, these three steps are there for performing the subtraction operation. So we also have to complement the subtrahend when you are doing subtraction operation. So this is the hardware. This is the hardware implementation. Next one is the algorithm. This is the algorithm. Okay, this is the flowchart for performing addition or subtraction operation. What happens in this is, there are two flows. Subtraction operation, this side the flow is at this side. Addition operation is the flow at this side. Minuend, okay, I want to write. Write means if you have 1 0 0 1 0 1 and 0 0 1 0, what happens here is, consider that the MSB is the sign, or you can do one thing. This is A, this is B, and this both are 0 0. This is AS, AS, this is BS. Okay, don't consider this to be sign. This is number, 4-bit number. If you have to perform A plus B, then this, the upper number is called as augend, the lower number is called addend. This is augend, this is addend. In case you perform a subtraction, this is called minuend, this is called subtrahend. The first number, the top number, the number which is above the second number, this is minuend in subtraction and augend in addition. This is subtrahend in subtraction and addend in addition. These are the names given to these numbers. What happens is, you have minuend in A register, subtrahend in B register in case you are doing subtraction. When you are performing addition, augend is in A, addend is in B. Okay. So next what happens is, you have to compare. What you have to compare? This AS and BS. When both are same. In addition, when both are identical, what operation you perform? You perform addition operation. When both are same, because here you are performing XOR operation between these two. XOR operation, what is the result in XOR operation? For 1 1 it gives 0, for 0 0 it gives 0, for 0 1 it gives 1, and 1 0 it gives 1. Okay, so when both are 0 0, and suppose we are doing plus not minus, AS XOR BS will generate 0 because both are 0 0. So XOR will give 0. When it is 0, then what you have to do? You have to perform addition. Addition result you store in AC, means accumulator, and E, any carry or any overflow bit you store in E. A is accumulator, E is extended bit. After you perform that, you copy the you transfer the E value into AVF. Okay. Next, what happens? You get the result. The result is in A and AS, because whatever is the sign of A, the same sign will be given as the sign of the result. That is, when both are positive numbers, means 0 0, and you are performing a plus operation. Next, consider you are performing a plus operation and one of them is a negative number. If you, oh no, not this is number, this one. If you give 1 here, it denotes that this B value is negative. Okay, so what you have to do? First you have to compare the signs AS XOR BS. AS is 0, BS is 1. What will be the output? 1, because XOR operation will give a value 1 when any one input is 1. When it is 1, we know that we have to perform subtraction, not addition. So you are moving to do this subtraction operation. So what you have to do in this? You have to first take 2's complement of B. To perform subtraction operation, the procedure is to add the minuend to the 2's complement of subtrahend. When you are performing subtraction, A is minuend, B is subtrahend. You are taking 2's complement of B. So A plus 2's complement of B. You are storing that difference in EA. And then AVF you are initializing to 0. And you are comparing if E is 0 or 1. Means E is like carry. When you get carry, when minuend is greater than subtrahend, you get a carry, you discard it. So you get a carry when A is greater or equal to B. A is minuend. Okay. If when A is smaller than B, here there won't carry is not generated. So it comes this way. Now what is the value of A? 1 2 4, 4 plus 1 5. This is 5 and this is 2. So a carry will be generated. A carry is generated means what you have to do? You have to check what is the value of A. If A is having all zeros, then you have to give the sign bit of A as 0 because you don't want negative 0. In case A means here A is accumulator. In case here if accumulator is 0, then it's like after subtraction there is a possibility of getting 0 when both the numbers are equal. In that case you have to mark the 0 as positive. This is that. If A is not equal to 0, then you get the result that is the difference in A and AS. In AS you will have the sign of A, because A is greater than B here. So you get here you get the sign of the result also 0, means positive. When A is like smaller than less than B, then what is the third step? The third step is you have to take 2's complement of the result again to obtain the difference. You are taking the 2's complement, this is 1's complement, then you are adding 1 to it to get 2's complement, and then the sum, the sign will be complement of as. As is 0, you make it 1. 1 means negative number. When you are doing subtraction operation, when both the sign bits are identical, you perform negative operation. When their signs, then the signs of the numbers are uh, different, then you actually perform plus operation, not subtraction operation, and then it continues. That is about um, performing addition and subtraction using signed magnitude representation. This another algorithm is addition and subtraction with signed 2's complement. In signed 2's complement, you just require two registers and a complementer and a parallel adder and overflow. This is the hardware for sign 2's complement addition and subtraction. What happens in this? When you have to do addition, you do augend AC and addend BR, and then you add both and store the result in accumulator and overflow in V and end. When you perform subtraction, minuend in AC, subtrahend in BR, and then you do this 2's complement of BR, add with AC and get the result, and overflow is stored in B. This is the algorithm for adding and subtracting in signed 2's complement. This is adding and subtracting using um, signed magnitude. This is signed magnitude. This is signed 2's complement. Did you understand? Do you have any doubts? Tomorrow we will study multiplication algorithms. In this, if you get any doubt, just go through and you can ask me if you have any doubt. Yes, uh, Saraswati, Bhavana, Pavani, Shravani, any did you all understand this? Any doubt if you have? हाँ हाँ हो गया था मेरा ऐसे वही बोलते ना No doubts? Okay, sit and practice. Take some numbers. Now I am giving you an assignment. Okay. Uh, take numbers A and B and perform addition, subtraction with all combinations: minus A, plus B, minus A, minus B, plus A, minus B, plus A, plus B. All this you try to do it. Okay, if you do, you will learn. If you learn while doing, you will get doubts. Tomorrow you can ask me. Okay, I'll stop the class now. Bye.